The James Webb Telescope has provided the oldest and most precise image of Proxima B, revealing astonishing insights about this potentially habitable exoplanet. As we set out on an adventure through space to discover Proxima B's mysteries, we seek to find out whether it could be the next Earth. This intriguing planet exists within the star's habitable zone. Proxima B is not your typical Proxima Centauri ordinary rock. It's Earth's cousin, located just 4.2 light-years away from us. This planet is shrouded in mystery. Could there be another Earth with oceans and life flourishing on its surface? But Proxima is more than that. Proxima Centauri is more than meets the eye. It isn't alone in its orbit around the red dwarf star. It has a companion whose identity is unknown. Additional secrets that the star system holds. Perhaps there's another planet that we have yet to discover. Proxima Centauri B receives roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface and perhaps even life? As we venture beyond our own solar system, we encounter a vast universe of exoplanets, planets that orbit stars other than the Sun. With approximately 200 billion stars in the universe, the possibilities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star, like rebellious explorers in space. Among them all, Proxima Centauri B stands out as a particularly striking and fascinating planet, whose year lasts only 11.2 Earth days. It travels around its star at a distance much closer than Earth is to the Sun. This means that likely one side of the planet is perpetually bathed in sunlight, while the opposite side remains in eternal darkness. Now let's discuss the star that Proxima B orbits. Proxima Centauri is part of the triple star system, which also includes Alpha Centauri A and B. These stars combine to form the closest star system to our own solar system. Alpha Centauri A and B are a binary system, appearing as one star in the Centaurus constellation and are the third brightest stars in our night sky, with a magnitude of less than 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star located 2.1 light-years away from the other two stars, roughly 4 times the distance between the Sun and Earth. Its name implies its proximity. Proxima means nearest in Latin. Discovered in 1915 by Scottish astronomer Robert Thorburn, Proxima Centauri, despite being the closest celestial neighbor to us, is not visible to the naked eye. It has an apparent magnitude of 1113, which is much fainter than the visible limit of 6.5. Nonetheless, don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a great deal of energy, but the internal core convection processes keep them shining for trillions of years. In fact, Proxima Centauri will remain a stable main-sequence star for an additional 4 trillion years. However, the habitability of a star like Proxima, a red dwarf, is still up for debate. For one thing, it is a flare star, which means it experiences regular and intense variations in brightness. For a star with a low mass, the habitable zone would be much closer than the Sun's, projected to be between 0.23 and 0.54 AU. However, it's not as livable as it appears. Proxima B is bombarded by intense ultraviolet radiation from its star, many times stronger than the radiation we receive from our Sun. This radiation is so powerful that even the lightest particles of hydrogen could be stripped away, not to mention nitrogen and oxygen. But just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a climate that is stable, which is crucial for regulating temperature and maintaining a surface that is water-friendly. Without it, living organisms would be vulnerable to harsh space weather, making life almost impossible. So, while Proxima B might seem Earth-like on the surface, it is far from being able to support life. Many remain skeptical, as various factors render it unsuitable for habitation. The quest to uncover the truth about Proxima B continues. Some still hold hope. One instrument that has captured the attention of astronomers is the James Webb Telescope. After several delays, the telescope was finally launched in 2021 and will assist us in determining whether there is life on Proxima B. As with all scientific endeavors, things are never as clear as they seem. Various modifications were required to ensure that the James Webb Telescope provides precise images. Abby Bend, a theoretical physicist at Harvard, explains that if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope is specifically designed to detect infrared light, capturing images of this light on the planet's surface and searching for patterns that could confirm the presence of water or an atmosphere. However, what if there is an atmosphere on the planet that isn't good for life? The mere presence of an atmosphere doesn't guarantee the existence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be similar to Venus, with a thick atmosphere that is generally denser than Earth's, accompanied by scorching temperatures that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima B isn't without its challenges. As long as the James Webb Telescope is in use, there are other factors to consider. With costs mounting, astronomers feel the pressure to find a way to observe planets like Proxima B. The stakes are high, but the rewards are even more significant. Opportunities to investigate the unknown and unveil the secrets of a distant planet that holds the potential for life are a pursuit worth pursuing. If the exoplanet were habitable, could we one day visit it? Being the closest exoplanet to us makes it especially exciting, almost like exploring our infinite backyard. Even more captivating is that it's pretty much the same size as Earth, and its position in the habitable zone suggests it could indeed have life-sustaining conditions. Proxima B's proximity also makes it an ideal target in our search for life beyond Earth. With it being so close, it presents an incredible opportunity for interstellar missions. Imagine the chance to investigate this exoplanet like Earth. Even though we are unable to go there yet, it is definitely on the agenda for future missions. As technology advances, it is one of the most thrilling quests in the field of space exploration. However, it's no simple task. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Despite this, a solution has been proposed. Extremely thin solar sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima alongside it. This technology utilizes solar pressure to keep the spacecraft on course, eliminating the problem of running out of gas. Even cooler, this cutting-edge technology could provide insights into the possibility of life on other planets, like Proxima B. However, as with anything ambitious, there are limitations. For example, the presence of an atmosphere does not always guarantee the existence of life. Proxima B could be akin to Venus, with a thick, hot atmosphere that is hostile to life. The James Webb Telescope can be used to detect this kind of light if it reaches only 5% of the dayside's brightness. Now, 5% may not appear to be much, but when dealing with a star that is usually quieter than our Sun, it is significant. If Proxima B has advanced technology, it might be utilizing orbital mirrors to reflect sunlight from the day side to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being colossal gas giants, whereas others are similar to our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space specialists is the gas giant. These planets are comparable in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been dubbed super Jupiters, overshadowing even the largest planet in our solar system. But there's more. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching environment with temperatures sufficient to melt metal. Imagine seeing such a planet up close, with its violent storms and intense heat. In addition to gas giants, there are also Neptunian exoplanets, which have sizes similar to Uranus and Neptune. Among these are hot Neptunes and mini-Neptunes, which are smaller and closer to the stars they orbit than their gas giant cousins. These planets often remain a mystery because their atmospheres are difficult to study from a distance. We shouldn't overlook terrestrial planets, which resemble our own Earth. These planets vary in size, from being smaller than our planet to twice its size. There are even super-Earths, which have masses over twice that of our planet, but are lighter than Neptune. One of the most intriguing exoplanets recently discovered is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a super-Earth with a rocky mass of 7 Earth masses. Although it is close to its host star, it is still within the habitable zone. Proxima Centauri B is not alone. It has a companion, Proxima Centauri C, which is a great deal further away from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2012 using pre-recovery Hubble data. What's even more interesting about Proxima C is that it appears to be an exceptionally bright world, possibly because there is a ring system. There's more to uncover in. Discoveries are being made all the time. It's an exciting time to be an astronomer. Even though we do not yet have an exact count of exoplanets, we do know they exist, just as we are aware of the stars that illuminate the universe. However, exoplanets are not easily detectable, involving cutting-edge technology and sophisticated telescopes to identify them. These planets are frequently obscured by the spotlight cast by their host stars, making them difficult to study. Nevertheless, as a direct result of technological advancements, exoplanet imaging is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot enough to be seen from Earth. These criteria limit the number of exoplanets that can be seen directly, but they provide fascinating glimpses into the characteristics and composition of exoplanets. From these distant worlds, exoplanets are most commonly discovered through the changes they induce in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope utilized the transit method, measuring the dimming of a star's light when an exoplanet passes in front of it. This method has been extremely helpful. Information about exoplanets, including their size, distance, and temperature, is gathered this way. Here are some fun facts. Did you know that more than 22% of stars like the Sun have planets the size of Earth in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets in our solar system can also have natural satellites known as exomoons. With over 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets are waiting to be discovered. NASA's James Webb Telescope is revealing these secrets one discovery at a time, exploring the universe. This remarkable telescope has been gathering data and capturing stunning images of the universe, revealing previously unknown wonders. Recently, it made headlines with a groundbreaking discovery that will forever change our comprehension of the cosmos. NASA reported that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides vital information about the planet's composition and evolution, offering us a glimpse into the secrets of the universe. This gas giant planet revolves around a sun-like star 700 light-years away, and this finding represents a significant step in our quest for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery will offer us a new perspective on the universe that we've never seen before, igniting excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy capturing extraordinary images and gathering data concerning the universe in infrared light. From a young, outflowing protostar named L110 IRS-4 It illuminates the cool, wispy cloud material, while the orange dots behind the cloud reveal the light from distant stars obscured by the ice in the cloud. This remarkable study was part of Webb's Ice Age project, which aims to investigate the evolution of ice from its formation, contributing to the onset of cold. The James Webb Space Telescope has also mapped the inner workings of a dusty disk surrounding a nearby red dwarf star, imaging it for the first time at these light frequencies in the infrared. This discovery provides significant insights into the formation of planetary systems and could help us understand how our own solar system was formed. The James Webb Telescope has offered unprecedented views of Proxima B, revealing exciting possibilities about this potentially habitable exoplanet. As scientists study this intriguing planet, which resides in the habitable zone of its host star, Proxima Centauri, they aim to uncover whether it could be akin to Earth. Located just 4.2 light-years away, Proxima B is often described as Earth's cousin. The possibility of water and life existing on its surface has generated significant interest. Proxima B orbits Proxima Centauri, a red dwarf star which is part of the Alpha Centauri star system, along with Alpha Centauri A and B. These stars are the closest to our solar system, and although Proxima Centauri is the faintest of the three, it's a stable star. Red dwarfs like Proxima Centauri have long lifespans and are among the most efficient in energy production, shining for trillions of years. However, they can also exhibit intense stellar flares that might pose challenges for any potential life on nearby planets. The habitability of Proxima B is still debated. Despite being in the appropriate zone, it might not have a stable atmosphere essential for protecting potential life from harmful radiation and temperature extremes. Proxima B's intense exposure to ultraviolet radiation from its star could strip away vital elements like hydrogen, nitrogen, and oxygen, making conditions harsh. Many scientists remain skeptical, noting that while the planet appears Earth-like in size and position, the actual conditions may not be conducive to life. The James Webb Telescope plays a pivotal role in investigating these questions. Launched. In 2018, it is designed to observe infrared light, which can provide clues about the exoplanet's composition and atmospheres. For instance, if Proxima B has a climate that stores heat or contains water vapor, the telescope could detect these signatures. However, Ed Turner, an astrophysicist, warns that the mere presence of an atmosphere doesn't guarantee habitability. Proxima B could look like Venus, with a thick, hostile atmosphere and extremely high temperatures. The quest for understanding Proxima B is not without challenges. Observing exoplanets requires advanced techniques to counteract the glare of their host stars. Direct imaging has become possible with technological advancements, allowing astronomers to get a look at the characteristics of these distant worlds. The influence of a planet's gravitational pull can cause its star to sway, resulting in detectable changes, while the transit method involves measuring the dimming of a star's light when a planet passes in front of it. Beyond Proxima B, the universe is teeming with exoplanets, each offering unique insights into planetary formation and evolution. Some of the most exciting discoveries include gas giants that can be significantly larger than Jupiter, as well as smaller terrestrial planets that might bear similarities to Earth. The variety of exoplanets includes super-Earths, which can have rocky compositions and sizes greater than our planet, and hot Jupiters, which orbit close to their stars. As our understanding of exoplanets deepens, so too does our appreciation for the vast diversity of planets that exist in the universe. The discovery of potentially habitable exoplanets like Proxima B has ignited hope and excitement, encouraging the scientific community's desire to uncover the mysteries of life beyond Earth. The James Webb Space Telescope, with its groundbreaking capabilities, is at the forefront of this quest. Its ability to investigate the infrared light produced by distant exoplanets is revolutionizing our ability to study their atmospheres, composition, and potential for habitability. As it continues to unveil new discoveries, the telescope is providing previously unheard-of insights into the nature of distant worlds, guiding us closer to answers about the existence of life beyond our solar system.